Hey everyone, how's your week going so far? So far, so good?
Yep.
Wonderful, wonderful. It's great to see everybody. All right, you ready for class? Yay, look at all you guys being on time. I love it. Really helps me when when you guys come on time. Helps us to get started right away, especially in some of the classes we move really quickly. So being right on time is helpful. All right. Anybody have any questions about anything you learned last week or that you've done the first couple days of this week? Shmuel,
I did the experiment with pre-prepared Jello and nothing happened.
it didn't work with the pre. Okay, well that's interesting. So when you have something like that happen, you can still do your lab report. You can still write it up exactly as it was. What you do when you submit your report is you just tell what you did and you tell what happened. And a lot of times we learn as much or more from experiments that don't turn out the way we thought they were going to as the ones that do. So we'll talk a lot about this next Wednesday when we have class. We will go over the results that you all got, and we'll do some comparison and we'll do some troubleshooting to see what we think some of the possible reasons for things were. But that's good. It's good that you try. Just never know. All right. Any questions? Any other comments or things you want to share now? All right. I'm going to go ahead and share my screen with you. As always, if you don't see the screen, let me know. I always have some kind of PowerPoint here to share or some presentation of some kind. All right, so we are going to talk today about what science is, but before we do that, I told you guys that I was going to start taking off some points for spelling and grammar, and we're getting close to that now. So you'll be turning in some written work, the exam soon, and I will be looking for spelling and grammar errors starting with that lesson. Now, I'm not going to take off a lot of points. As I said, maybe a quarter of a point for something that has multiple errors in it. But I just want you guys to learn to use proper grammar when you're doing school subjects. Now, there's a lot to grammar. Those of you who have taken English classes know there's a lot to English grammar. We do not have an easy language, but there's just a few rules that I want to go over with you to, things that I have noticed, how common errors and things that I want to be looking for. And of course, grammar matters because it can save lives. It's the difference between eating grandpa and inviting grandpa to come for lunch. Let's eat grandpa or let's eat grandpa. All right. So what's important for this class? Well, capitalization is first. Please make sure that you capitalize the first word of every sentence, that you capitalize the personal pronoun I when you're talking about yourself, and you capitalize the names of specific people, places, and things. So an example would be when you were talking about Francisco Reddy, you would capitalize his name because that would be a specific person. All right. The next one is please use full sentences. Don't just give me a clause or a phrase. Give me a complete sentence that has a subject and a predicate. So usually a predicate is a verb, an action word. So that's what I'll say. Make sure that your sentence has a subject and a verb in it. And then finally, and with regard to sentences, don't begin your sentence with the word because. It's really best not to. There are a couple of situations where it's okay to start a sentence with because. There's really only two. One is where you're using it in place of the word since. So you can start a sentence with because when you have two parts, two clauses separated by a comma like this one. Because the plant did not grow, I hypothesized there was not enough water. Or you can use the word because when you're speaking conversationally. So here in class, if I say to you, why didn't the plant grow? You can say, because we didn't water it. That's perfectly fine. When you're doing written assignments, so it's really best not to do it. And finally, punctuation. Sentences always end with some kind of closure, some kind of punctuation at the end. If it's a statement, it's going to be a period or an exclamation point. If it's a question, it's going to end with a question mark. So that's pretty easy. 3 rules: capitalize, full sentences, punctuation at the end. All right. Anybody have any questions about that? All right, great. Now be sure that you are getting the announcements. If you didn't get the announcement this morning to your email telling you that we have class, please go back into that course information module, look at the assignment that starts with urgent, and verify your email address. The reason that's important, if anything ever happens and I can't hold class, that's how I'll let you know. And if you don't check your email or you don't get it to your email, you won't know, and you'll be sitting here wondering why we don't have class. Now, I've never had that happen before, but you never, it could happen at some point, or maybe AIM Academy has a problem or Zoom has a problem. I can send it to you through your email in that way. Shmuel.
I received an announcement, but not an email. Was it an
Okay.
announcement or an
Yeah,
email?
that means you need to go into the course information module, look at it's the very top one at the top of the list of assignments, and it starts with urgent. Make sure you go through those steps. It's also possible that when your parent signed you up for AIM Academy, they use their email address and not your own. So in that case, you'll want to add your own if you have one, just so somebody's getting it. If your parent gets it, that's fine. If you don't get it and your parent does, that's okay. All right. Speaking of messages, when you send me a message through Canvas inbox, please be as specific as you can. Tell me the page number if you're asking about something in the book. Tell me the name of the lesson. All of my lessons have numbers and then a name. You can just give me the number because they're all in order. Give me the quiz question number. Give me as much information as you can so that I can help you as quickly as possible. So we don't have to keep going back and forth until I finally understand what it is that you're asking. And what do you do if your teacher is late to class? Anybody know what the sort of rule of thumb is for a teacher being late? Rudra. I'm not hearing you. No, microphone might not be on. All right, let me check here. Mic isn't working today. It's 15 minutes. It's 15 minutes is what you want to give a teacher to allow them time to get to class a little bit late. Now, if I have a class before this one and it runs a few minutes late, don't come here on the hour and say, oh, I guess we don't have class today. Give me that few minutes. Like I said, it's never happened before. I've never been significantly late to a class before, but it could happen. All right, somebody asked a question here. Ileana says, when writing lab reports, do we use the pronoun I or we? We'll talk about that, Ileana. It's best not to. It's best to avoid using first person in a lab report. The first lab report that you do, I'm going to be pretty flexible. I'll just remind you that it's best to use third person. So instead of saying, I put the pineapple on the Jell-O, you would say, put the pineapple on the Jell-O. You just avoid that altogether. We'll go over that next week when we talk about how to write a lab report. All right, so let's play a little game here, a little get acquainted game for the first couple of classes that we have, just so we can get to know each other. The more we know each other and the more comfortable we all are with each other, I think the more fun we can have in class. So you can type your answer right into the chat box and I'll read them out as we go. I'll try not to laugh. Some of them will make me laugh, I'm sure, but I will also try to read as many as I can. All right, so using just one word, name something that makes you happy. What makes you happy? Yes, see, laughing already. I knew that Lillian was going to say cats, and I knew that Eleni was going to say books. All right, food, books, food, climbing, reading, art, games, fun, gaming, keyboards all together, like any keyboard. That's a good one. Anything with the keyboard makes Ayub happy. Sleep makes Rudra happy. Yeah, also reading. Yeah, reading with a cat on your lap, right? There you go. Morning sleep. All right, I know how you're going to answer one of the questions we have here then, Rudra. All right, next question. Describe yourself using just one word. A little more philosophical. Annoying, tired, ludicrous, slow, chaos, lazy, aw, amazing. So any of these that are negative, we can change. Nerd, distracted, annoying. Yikes. You can work on yourself, right? We can do that. We can make changes in ourselves if we're not happy with something. And the ones that are, I love too many random facts. Yeah. Bibliophile. Oh, there's a reader for you. Excellent. My favorite place in the world is the library. If somebody said to me, if you could only go one place and you had to live in one building for the rest of your life, it would be a library for sure. All right. Next question. What is your least favorite food? Anything slimy. Ooh, like what? What's slimy? Pistachios. Yeah, I'm not crazy about natto either, AU. Turkey. I got food poisoning once with turkey, so I'm up there with you. It's not fun. Olives, which make no sense because yeah, you'd think olives would be one of your favorites. Squash, okra, and natto. Yeah. Nuts, can't pick just one. I don't know the name. Anything green. Something like kale, meat actually, but it's wet. Yeah. Zucchini. Yeah, zucchini has, you have to cook zucchini perfectly. Zucchini that's cooked perfectly so that it has just the right crunch is really good, but cook it a little bit too much, then it's really mushy. Then that's what would be slimy. I would say that's slimy. Yeah, I can't tolerate okra either. Meat other than seafood. All right, excellent. All right, so here we go. How about this question? If you could have 25 hours in each day, what would you do with the extra one? I knew sleep was going to show up there a few times. Play games, read, study, cook. Excellent. Every family needs to have one person who loves to cook and one person who loves to clean. Wouldn't that be wonderful? Doesn't have to be the same person, but study, because I have not enough to do homework as it is. Cats, sleep, read with cats and sleep. There you go. Do it all together. Plot. Ooh, you're a plotter, Ava. All right. Read whatever I want to do. So it would be a little something different every day. Yeah, whatever you want to do that day. Excellent. There's another question. If you could have 20, oh, no, that's the same one. There you go. If you could be in the Guinness Book of World Records, what record-breaking feat would you attempt? Oh, I hope not world domination. Very fair overlord. Yeah, have you heard the saying, power corrupts and absolute power corrupts absolutely? Yeah, so plotting world domination might not be the best thing. All right, laziest person on earth, most books read in a day. I beat 2 world records, but they were in a video game. Rudra, did you really? You really beat a world record? For what? What game?
It was a Roblox game.
Well, that's pretty cool. We have a celebrity in our midst, everybody. Most hours procrastinating, most hours of sleep. Probably go for the most TV series. Yeah, that's a problem with those streaming services, isn't it? Boy, you can just get sucked into a TV series real quickly. Let's see here. Fastest traveling to every capital of every country. Ooh, I love that one. I would love to travel that much. I don't know about like everyone. Well, yeah, everyone. Most hours procrastinating, daydreaming, reading, most time without sleep. Now, Umar, everybody said they wanted more sleep, but you're saying most hours without it. I love it. Isn't it great how we all have different interests? All right. The last question is, using just one word, name something that drives you crazy. Yeah. Siblings, brothers, brother, social. Ayub. Ayub sent me a private one. I won't tell her. Pretentiousness, unintelligence. Well, Get used to that. There's a lot of that in the world, unfortunately. All right, excellent. So you guys that put down your siblings, you know, odds are really good that when you're an adult, your siblings are going to be some of your favorite people. But right now, I'm sure they seem like they just drive you crazy. All right, excellent. Okay, finally here, name one step in the scientific method. She's right, Shmuel, she's right. Hypothesis, observation. Got a lot of observations there. Procedure, gathering data, hypothesis, conclusion. You guys got most of them here. Making a hypothesis. How about experimentation? That's a big one. That's the most fun one. I think actually running the experiment is the most fun part of it. Ask a question. Great. Research. Yep. Yep. All right. Well done, everybody. That was good. I'll have a couple more questions for next week. Eating the experiment. Well, be careful. You don't want to eat anything that your science teacher doesn't tell you is safe. Got to be careful tasting science experiments. That can get you in big trouble. All right, let's talk a little bit about this Jello enzyme lab and lab report. So this week, the lab is due. It's due the end of the week. Next week in our live class, we'll talk about how you write up your lab report. And then the report will be due on Friday of next week. So that gives you time to get it done. Now you can do some of it as you're going. Taking good notes as you're doing your experiment is really good. But what I want to do today is I want to, yeah, it is cute. I want to walk you through the steps of the lab for those of you who haven't done it yet. So always start every lab procedure by reading the instructions start to finish. Read from the beginning to the end before you ever even start it. Don't just open the page and do step one without knowing what you're going to do all the way through. Once you've read everything, then the next thing you're going to do is gather up your supplies and make sure you gather everything that you need. You want to make sure you have it all there so that you don't have to leave and go get something in the middle, because sometimes, not in this one really, but in some of them, time is significant. You want to make sure that you they're not missing some important supply. Next, then, follow the instructions exactly as they are written. I'm not going to read all that now because you guys can all read them as you're going through them. Please read them carefully, though, and then follow them exactly as they're written. Don't skip any of the steps. Don't do them out of order. Eleni, what if we can't get fresh pineapple? I do understand that's possible. You can do it without the fresh pineapple. It's just your results are going to be different. I can tell you that right now. The fresh pineapple is kind of important to this lab. You can still do the lab, though. You can still do it. You can still write up your lab report. You'll still get full credit. I'm going to be giving you credit based on what you do, regardless of what your supplies are. Just make a note in your lab report that you were not, you didn't have access to fresh pineapple. Okay. Do the cups have to be plastic or paper? They can be glass. Yeah, they can be glass. Yeah, they could for sure be glass. Just be careful. I usually give really safe supplies whenever I possibly can, and glasses can be knocked off. So if they're paper or plastic, they can't be broken. Could you do it with a different fruit? No. I mean, yes, you could. You won't get results. There is something in pineapple that is specifically interactive in this lab. So you could do it, but you're not going to get the results. If you want to do it with another fruit, feel free. You can always take your experiments farther than is required, adding something else. Or you could say that in your discussion section at the end of your lab report. You could say, this might be good to try with a different fruit, and then maybe suggest a fruit. All right. And then you have this chart right here. It looks like this that you'll use to collect your data. I recommend that you either print this or write it in your notebook, and make sure that you keep your data sheet and bring it with you to class next week, because I want to talk about our results before we talk about how to write up the lab report. All right. Anybody have any questions about doing the lab? The thing that burns your tongue when you eat pineapple. Okay, here's a question for you. How many of you get some kind of reaction when you eat pineapple? You have some kind of not fun feeling in your mouth when you eat fresh pineapple. Raise your hand if you're one of them. Yeah, I am. I can't eat fresh pineapple. Yeah, I actually get little like little ulcers, little tiny sores in my mouth when I eat fresh pineapple. So we've got a few here. I do, let's see, Shmuel, Ava, Umar, Rudra says it's just sour. Ileana, scratchy tongue. Umar, it hurts my tongue. Nothing for me. That's fine. That's fine. So one of you just said that you got something going on and you're not able to do the experiment now. You can do the experiment later, a month from now. Remember, I don't take off points for things that are turned in late. So even if you do it a month from now, 2 months from now, I'll still accept it. I'll still grade it. I just think it's best to try to get things done as best you can for all the reasons that we talked about last week. Cousin thought I was crazy when I said the pineapple was sour. Yeah. So yes, it is the thing that affects the inside of your mouth. So I'll tell you what it is because you could easily look it up on your own anyway. It's an enzyme called bromelain. So we're learning about enzymes now and how enzymes change. They actually speed up chemical reactions. Well, this enzyme called bromelain is inside pineapple. And for some people, it actually begins to break down the lining of the inside of your mouth. So tomatoes have a little bit of an enzyme that does the same thing. So maybe some of you can't eat fresh tomatoes, but like I can eat canned pineapple, but if I eat fresh pineapple, it really bothers my mouth. Yeah, it does sound kind of morbid. It does, but it's that if you've ever used meat tenderizer, have you ever sprinkled meat tenderizer on meat? That's not so commonly done anymore, but it used to be done a lot when meat cuts were really tough. You could sprinkle a little bit of this meat tenderizer. Guess what meat tenderizer is? Bromelain. It's the same thing that's in pineapple. It begins to break down. It's an enzyme that breaks down the meat. It begins to break it down same way it breaks down the meat on the inside of your mouth. So yes, it is. All right. All right, let's see here. So if anybody, this is going so fast in the chat here that if I missed a question, ask it again or raise your hand and ask specifically. Sometimes I just don't see them when they go by so quickly. All right, moving on. We won't spend a lot of time in this class talking about the periodic table. That's really for your chemistry class, your physics classes, but it's really important that we remember that everything in the universe, including all living things, is composed of different combinations of these elements. Now, there's 118 of them on the periodic table, 118 known elements, but only the first 91 are found in significant amounts in nature. The rest of them are made in laboratories. Now, between 92 and 98, they are found in very small amounts in radioactive compounds, but for the most part, it's the first 91 that we find in significant amounts in nature. Now, of those first 91, 4 of them make up 96% of living matter. Anybody want to take a guess which 4 makes up 96% of living things? Shmuel.
Hydrogen, oxygen, carbon, and nitrogen.
Very good. We have hydrogen, carbon, nitrogen, and oxygen. Now, most of the remaining 4 of any living thing's weight consist of just a couple things. Phosphorus and sulfur are 2 of them. Calcium and potassium are the others. So 96% is made of the 4 that are here in the red. And then the other 4 make up the most of the remaining 4. There's a couple trace elements that are in living things like iron and copper, iodine and zinc. You've probably heard of those. They might be in a multivitamin if you take one. So you've probably heard of those. They're only needed in very small amounts in living things. So you guys will notice in the carbon compounds lesson, I believe it's due tomorrow. Well, Friday, they're all due Friday. I believe there is a lesson or a video about the periodic table of elements. Now, if you're interested in memorizing the periodic table of elements, you can stun your chemistry teacher in the future if you know all the elements on that table. But this song can help you. It's not required, but if you do, and you sing it in class, I'll give you 20 extra credit points. All right. Anybody want to do it now? Go for it, Lillian. Lillian was in my physical science class last year, and she memorized the periodic table singing the song. So I asked her if she would be willing to sing it again And you guys can see that it truly can be done. So if you memorize it and you're willing to sing it in class for 20 extra credit points, just send me a Canvas inbox message when you're ready, and I'll fit you into our next live class. All right? Go, Lillian.
Hydrogen and helium and lithium on carbon everywhere, nitrogen all through the air with oxygen so you can breathe in, fluorine for energy, neon to light up the sign, sodium for salty times, magnesium, aluminium, silicon, phosphorus, then sulfur, chlorine, and argon, potassium, calcium, so you'll grow strong, scandium, this is the period. Stable halogens and alkalis react progressively. Each period will see electrons are moving to the right. Iron is at 26 and cobalt, platinum, copper, zinc, and gallium, germanium, and selenium, chromium, krypton, hydrogen, yeah. Zirconium, technetium, ruthenium, rhodium, palladium, silverware, cadmium, and indium, tin cans, antimony, then tellurium, and iodine, xenon, and then cesium, and barium is 56, and this is where the table splits, where and always have just begun. Lanthanum, cerium, and praseodymium. Is next to promethium, 62, some terbium, dysprosium, thulium, erbium, thulium, ytterbium, potassium, tantalum, toxin, then one to radium, osmium, and radium, to make it rich all your gold. To tell you when it's really good. Polonium, then lead and bismuth, thorium, polonium, arsenic, niobium, uranium, francium, also time radium, then acantized today. This is a periodic table, noble gas is stable, halogens and alcohols react impressively. Each period will see new electrons, the electrons at the right, actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium. Sorry, these are always way too fast.
Yeah.
Memorize them all.
That's all right. I think we're going to give it to you. That was well done. Yeah. Great job. Great job.
Lawrencium, Rutherfordium, Seborgium, Copernicum, Nihonium, Flerovium, Moscovium, Livermorium, Tennessee, Organism, and then we're done.
Yay. Very well done, Lillian. That was excellent. Excellent. That's 118 of them. Pretty cool. So I also thought you guys might enjoy watching Harry Potter sing a song about the periodic table. Now, it's not really Harry Potter. It's the actor, of course, Daniel Radcliffe, but it's kind of fun. So let's watch this.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and uranium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and anthium, and osmium, and acetine, and radium, and golden, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, and terbium, actinium, rubidium, and boron, gadolinium, and opium, and iridium, and strontium, and silicon, silver, and barium, bismuth, bromine, lithium, beryllium, and barium. And let's start the next verse. There's holmium and helium. There's holmium and helium and appium and erbium, phosphorus and francine and fluorine and terbium, and manganese and mercury, molybdenum, magnesium, dysprosium and scandium and cerium and cesium. There's lead, praseodymium, platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, arsenium, nobelium, and argon, radon, neon, and argon. Hold on, quiet. There's sulfur, californium, and fermium, berkelium, and also mendelevium, arsenium, nobelium, and argon, radon, neon, krypton, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. Now,
Yeah, that's fun. All right. All right. I don't know. Why haven't you seen it before? It is fun. It is fun. All right. 20 points for Lillian. And anybody else, let me know. If you memorize it, you get 20 points. That's a lot. That's like 3 quizzes worth of extra points. All right. Last week, you guys read about some science basics, and we talked about the scientific method last week, and I want to talk more about it today because it is so important. So there was a section in What is Science in the lesson called What is Science? And that section was called Thinking Like a Scientist. And I want to talk about that because A lot of problems in life can be solved if we just think like a scientist. If we use the scientific method, we can solve lots of even ordinary daily life problems. Because when we're trying to solve a problem, really no matter what it is, there's a way we can go about thinking that'll be very helpful. It'll make it easier for us. We always are going to start with observations, and we want to observe detail when we're looking at something, when we're using our senses to try to imagine something. So imagine this. Imagine that you are sitting in a dentist chair for about half an hour and you're waiting for the dentist to arrive. What are all the things that you might observe in this room? Just give me some. You can say them out loud or you can type them in. TV screen, the tools, the seat, a big chair, yep, the different tools. The PC, the dentist is not very good at keeping track of time. Yeah, that's true. Half an hour is a long time to be late. A tissue box. Your dentist has games on the computer. I don't know, can't tell if there are there or not. The windows, the computer, the light. Now, so far, you guys have all used vision. Remember, we use all of our senses when we are observing. What else might you observe using a different sense? The leather seats, you might use your sense of touch to know what the seats are made of. Yeah, the smell. Dentist offices have a certain smell to them, don't they? Yep, you know if you're in a dentist office just by smelling. What else? What other sense? Drills nearby. Yep, definitely. Found an owl in the dots on the ceiling. That's fun. The electric toothbrush thing. Yeah. Artificial toothpaste in the air. It could be cold. It's often cold in dentist offices. Yep. Kids whining in the waiting room. Yep. True. You might hear the sound of someone walking down the hall, clicking their feet on the tiles or talking to somebody else. Sometimes there's even a taste in the air. You know, you might pick up that bit of taste from the dentist, the toothpaste that they use. So we would use all of our senses to observe the things in this room. Now, we want to use the same kind of detail when we are observing anything. Oh, okay, no problem. So let's apply what we just learned about observing and going into detail with observing to another scenario. So imagine that you are a scientist. You're out in the field studying elephants, and you observe a group of healthy elephants on the north side of a jungle, but on the south side of a jungle, there's a group of elephants that are mysteriously dying. So that's what we observe. We observe that they're dying. How could we make this observation more detailed? So wait, Rudra, what you're doing now, you're going now into possibly hypothesis. We're on observation. So you're on the right track. You're just a little bit ahead of us. So same thing. We don't want to be coming up with possible reasons why. We just want to observe. We want to watch what they do differently. Rudra, we want to watch their behavior. We could observe behavioral differences in them. We want to, the north side could be more livable for elephants. So maybe the environment, Eliza, good. Find out if other animals are dying. Exactly. We could observe other species. We could see if they're moving or not. Yeah, these are all good answers, and they're very good, more detailed observations about what's happening with the elephants. We want to observe whether or not age has anything to do with it. Is it only the young ones who are dying? Is it only the old ones who are dying? What about male or female? That can help us to narrow things down, because if we discover that it's only the newborn males who are dying, we're going to treat it very differently than if it's both male and female and they're older, right? We're going to approach that a little bit differently. The more detailed we can be, the better. So then once we've got our detailed observations, then we ask questions. We want the questions to reflect the detail in the observation that we just made. Now we can start with questions like where, why, what if, all the ones that are on there, but those aren't quite detailed enough. We want to get more detailed if we possibly can. So think of some questions that we might want to know about the elephants that we might ask, more than just why or where or how. What do they eat? Good. So basically, we would want to know, how is what they eat different from one side to another? How is what they drink different from one side to another? Yeah, I know, it's probably not the best picture. Which ones are dying? What other animals live there? How are they dying? Yeah, exactly. What method of death are we seeing? Are they being affected by predators? What parts of their body? These are excellent, excellent suggestions. We want to basically look at the differences between at what we have observed in the differences between the elephants themselves and the environment that they're in. And then we want to ask some questions. Now, we could go in a lot of different directions with this. Let's pick food as our direction, just because we have to pick one to move forward. So let's say there isn't enough food, or that's what we observe. We observe that there appears to be a lack of food on one side of the jungle, on the south side. So let's say that our question is there enough food on that side of the jungle? So what could we do to test that? If we wanted to test whether or not they were dying because they didn't have enough food, how could we test that? Shmuel.
We could move some of them to the other side of the jungle.
We could, yeah, we could move the ones on the south to the north side. That is something we could do. Yeah, Eleni says, find what they eat and search for it. So we could provide food for them, right? We could give them more food. We could explore the jungle and find their food sources. Yep. Yep. So let's say that's what we decide to do. Let's say we decide to, for simplicity, it's probably going to be easier for us to provide food than move all the elephants. So let's say we're just going to provide food to the elephants on the south side and see if they die. Now let's turn that into an if-then hypothesis. If I do something, then something will happen. Now we'll talk next week. I'm not going to use the word I in a hypothesis. I'm going to stay third person. But for the sake of discussion today, we can say, if I do something, then something will happen. What would the if part of that be? If we, yep, if elephants are given food, good. That's an excellent way to do third person. If we provide the elephants with food, good. Yep, we want to change one variable at a time, Ruger. You're right. You're right. So if we provide more food, yeah, Leo, perfect. That's, you've got the then there as well. Then they will survive better. But we don't want our hypothesis to be in the form of a question. So all you have to do, Leo, to make that perfect is say, if we give the elephants more food, then they will survive. Okay, you see the difference. We don't want it to be in a question form. We want it to be in a statement form wherever we can. If the elephants are provided with food, then they will stop dying suddenly. Good, excellent. What is the independent variable in this? Independent variable is the one you change. What are we changing? Food. Yes, food is the independent variable. What is the dependent variable? Dependent one is what you measure. It's more than just elephants. It is the elephants, but it's more. It's the life or death of the elephants is what we're going to be measuring. That's what we're going to be looking for. Excellent. And then we got to do our experiment. We already know what our experiment's going to be because we wrote it right into our hypothesis. If we give them more food, that's our experiment. We're giving them more food. Now, an experiment tests to see if that hypothesis is right or wrong. So let's suppose that we are gonna give them more food, and then we're gonna gather our data, and we get our data back. The next thing we're gonna do is question our data. We're gonna question the answer because scientists question their answers. What does that mean? What does it mean to question an answer? Shmuel.
To say like, why did that happen? And or like, did I do something wrong?
Yeah, well, you want to kind of check for those things. You want to check what happened, check to see if you did something wrong. Skeptical is a good word, Ileana. Good scientists are skeptical. Scientists never use just one piece of information to come to a conclusion. So let's think about, maybe we give them more food and they stop dying. Does that necessarily mean that they stopped dying because they didn't have enough food? No, there could be other reasons. Maybe when we gave them this extra food, they stopped eating a poisonous plant they were eating before. Now they're eating a plant that isn't poisonous. So it wasn't lack of food, it was the wrong food. So we want to run our experiment repeatedly. We want to question our results. We want to find other scientists to either confirm or disagree with the evidence that we have. We might change another variable. Yeah, it could have been the season. There's a lot of possibilities. So we want to question our answers. Never go with the first thing that comes to mind. All right, let's look at this word here. I want to talk a little bit about this. We're stepping a little bit away from the elephant story a minute here to talk about theory. So when you hear the word theory, we often just think it's somebody's guess or hunch or opinion about what's going to happen. But in science, the word theory means a lot more than that. In science, a theory is an explanation that is supported by scientific evidence, and it's usually pretty well supported. It's well established, it's well tested, it has been developed through repeated experiments over long periods of time, often by many people. So an example of a theory that we believe now is the theory that matter is made up of atoms. Now that's a scientific theory. We accept it. I know I love the Amoeba Sisters too. We accept it. It's a well accepted, it's well supported by scientific evidence. So this is one of the fundamental principles of basic science. But as scientists, we also have to be open to changing our theory when new evidence comes along. You guys learned one of those last week. So last week you learned this spontaneous generation theory. People held this for a long time, and you can understand why. People started seeing things where there wasn't anything alive before, like the fruit flies in my kitchen. When there wasn't a fruit fly a minute ago, they must be coming from the dead bananas. They must be spontaneously generating. So you know how you can understand how they thought that. But this guy, Francesco Redi, he came along. He didn't think spontaneous generation was true. So he did the experiment where he covered some of his jars with gauze, some of his jars with parchment. And his theory, his hypothesis, of course, in if-then format was if flies are prevented from getting to the meat, then no maggots will appear on the meat. So he designed this experiment testing only one variable to make sure that the differences that he observed were caused by that variable. And he controlled all the other variables. He made everything else stay the same. He didn't put a different kind of meat in the different jars. He didn't have a different temperature in the rooms or different light levels. Everything else was kept the same. So in his experiment, what was the independent variable? Independent variable is the one you change. You're going to make me sing it every time. Independent variable is the thing you change. Yeah, it's going to be something covering it, whether it was covered or not. Either the gauze or the parchment was his independent variable. So what was the dependent variable? What was he looking for? The presence of maggots, or yeah, exactly. If the maggots appeared on the meat or not. All right. Now, there's another theory that was disproven. It's another one. There have been a lot, but this is a kind of interesting one to me. This is called the blank slate theory, and this was really popular back in the 1600s. This theory said basically babies are blank slates, that they're born with no built-in mental content, that everything that they get comes from their experience. Now, we know now that genetics plays a big role. A lot of what you are is because of the genes that you inherit from your parents. So you're not a blank slate. You come pre-programmed with a lot of things that are going to make you who you are. Also, we know that babies have some innate instincts, and those play a really important role. So this theory was disproven. There is, though, an important and true scientific theory, at least based on what we know now. Again, as scientists, we need to be open to changing our theories when new evidence comes along. Significant evidence, not just one little piece of something. Like I said, scientists question the results. But one really important one, and really important for biology, is the cell theory. So the cell theory has three parts to it. This is an important one for you guys to remember. The cell theory says all organisms are made of one or more cells. All cells come from cells that existed before, and the cell is the basic unit of structure and organization that performs life's functions. That last one is a lot of words. Basically, what it means is cells do the things that make life possible. Life exists because of cells. So all organisms are made of one or more cells. All cells come from pre-existing cells, and cells do the work of life. So based on the cell theory, do you guys think viruses are alive? Viruses are not made of cells. Yeah, they're not made of cells. So given what we believe now, given the cell theory as it exists right now, we would say no, they are not alive. Now, I will tell you, there are some scientists who think we need to rewrite the cell theory so that viruses fit into the life category, because they have a lot of characteristics of living things, but not all of them, because they're not made of cells. Yeah. All right. Why do they have to be alive? Well, that's just what we've kind of said now. Wait, why do viruses have to be alive? You mean,
Yeah.
why do scientists want them to be?
Yeah, I mean, why can't you say they're mindless proteins that are helped by probability?
Yeah. That's what those of us who believe the cell theory would say. Yeah, I would say that they're not alive. And I think people struggle with viruses because, well, let's take COVID for an example. Wouldn't it have been really nice if we could get mad at some living thing for having disrupted our world the way it did? But you know what? It's not even alive. It's not even a living thing. You can't really get mad at something that's, just chunk of protein, or, a coat around DNA or RNA in the case of COVID. So yeah, I think people get a little too emotionally invested in their ideas. And so they want to change things so that their idea fits with what science would say. All right, so back to the scientific method. So one really important thing about this method is that it allows one scientist to reproduce another scientist's experiment. So somebody said a minute ago, I scrolled back here. Oh, here, Shmuel, Reddy's experiment was not enough to disprove spontaneous generation completely. You're right. There had to be more. There had to be more that came after. There had to be more scientists who did his experiment. There had to be more scientists who did other experiments that led to the disproving of the spontaneous generation. That's what part of why the scientific method is so important, because it allowed them to reproduce it and to build on it. So if you think about baking a cake, if every time you baked a cake, you use different ingredients or the same ingredients in different quantities, you wouldn't end up with the same cake. So just like that, just like it's important to follow a recipe when you're cooking, it's important to use a similar method in science. So we use the scientific method. Now, it's not only is this different, if you look up a bunch of different ones, they'll use different words. Some of them might use a different word for experiment. They might use, I'm drawing a blank here, something. Instead of analysis, they might use data. They might use that, but they're basically going to be the same things. And for you guys, for your purposes, one reason that you need to understand and know the steps of the scientific method is it is the format that you use to write a lab report. So we'll base our lab reports on the scientific method as it's written right here. So knowing these steps will help you. So let's use an example, a little cartoon example here to walk through the steps of the scientific method. So let's suppose that you get 2 slices of bread, you put them into the toaster, you push down the button, but your toaster won't toast. What is the observation? Step 1 is always observation. So Rudra, it's broken. That's not an observation. Again, you're going a little bit beyond. You're going into the possible hypothesis form. We just want to observe. Yeah, what we're observing is that our bread is not turning into toast. It isn't toasting. We don't know if it's working properly. We don't know. The only thing that we can observe, yeah, no toast. That's what we can observe. We're not getting toast. So we're going to observe it with our eyes. We can observe it with our smell, our sense of smell. You're not getting that warm toast smell that is very different than a bread smell. All the senses that we would use would tell us my toaster won't toast. That's my observation. Right after observation comes question. So scientists will ask a question based on the observations. What question might we ask? Yeah, why isn't my toaster toasting? That's a very good one. We want to try to get a little bit more detailed if we possibly can, though. So we want to start with why, but we can then make that more specific. Why isn't my toaster having a distinct lack of toast? Yeah, love that one. Yeah, why isn't my toast being toasted? Good. Those are all good answers. Okay, Yaya says, what's wrong with my toaster? Yes. So that could be, it could be, one of my questions might be, is my toaster broken? What's another one? It's another question I might ask that would lead me into the next step, which is going to be the hypothesis. Is it plugged in? Is there power? All right, let's go forward. Now we can do some research. Is the bread okay? Maybe it's some alien kind of bread that just doesn't toast. Seeing the word toast this many times make you hungry for toast? Everybody having toast for dinner? All right, so the next step is going to be research. Now, research isn't always required. Sometimes it is, though. You know, in this case, your research might be as simple as, Mom, why won't the toaster work? And now you've just called in an expert to come and help you to find a solution to your problem. Or you might go online. You might look up, you know, your toaster, find out what some of the issues are. So we can do some research sometimes. Now, the next thing we're going to do is we're going to construct a hypothesis. Now, remember, this gets a little bit confusing because a hypothesis, when it's well written in if-then format, has two parts. It has the hypothesis and the prediction. I think it's better to say the statement and the prediction, but most books will say the hypothesis and the prediction. The if and then the then. The if is going to be the hypothesis, the then is going to be the prediction. So let's say, for the sake of argument, that what we're going to assume here is that our hypothesis, our if, is maybe the outlet is broken. Maybe our outlet isn't working. So we want to make sure that our hypothesis is something that we can test. It is something in a testable format. We couldn't say my toaster doesn't like this kind of bread. That's not testable, right? So we have to put our hypothesis and our prediction in a testable format in one sentence. And we're going to have something like, if the first part is maybe the outlet isn't broken, if I use a different outlet, then it will toast the bread. Now, like I said, it doesn't always have to be if-then format. Sometimes the hypothesis could be something like consumption of sugary drinks leads to tooth decay. That's a valid hypothesis. But when we put it in an if-then hypothesis, it's much more, if-then format, it's much more valuable because that tells us what we're going to do and what we're going to look for. If I plug the toaster into a different outlet, then it will toast the bread. I know what I'm going to do, plug it into a different outlet. I know what I'm going to look for, whether or not it toasts the bread. I'm going to then test my hypothesis by plugging it into a different outlet and testing it again. Then I'm going to evaluate my data. My independent variable was plugging it into a different outlet. My dependent variable was whether or not it toasted. After I did that, I'm going to analyze my data. If the toaster does, yay, my bread toasted, then it's likely correct. My hypothesis is supported, and then I can communicate my results. If my bread still won't toast, then that hypothesis is not supported. It's likely wrong. Then I have to go back and try to think of something else. Now maybe it's that the toaster is broken. So I have to try again. If it showed that my bread toasted, my hypothesis was supported, then I am going to communicate my results. I'm going to either tell somebody about it. I'm going to write an article for a journal. I'm going to tell my story to a journalist who might write it up. And we're running real low on time, but I want to make sure I cover this concept right here. One really important thing about a hypothesis is it also has to be falsifiable. If it can't be proven wrong, well, if ones that can't be proven wrong are treated as valid, then you can see how that would have some serious implications for scientific progress. Because if you can't prove it wrong, it can't be tested in a meaningful way. So that means no new knowledge can come about. Could mean that science doesn't advance or that trust in science is eroded. And the whole scientific method could be undermined by that. So we have to be able to falsify a hypothesis. So an example might be something like there is an invisible force that influences human behavior. Yeah, tooth fairies, take your teeth. Yeah, so those are things that we cannot falsify. All right, so there are some challenges though that might come up when we distinguish between falsifiable and non-falsifiable. Think about something like theoretical physics. So theoretical physics, you can't test. It's all theory. You can't run tests in theoretical physics. Some of the social sciences like psychology, it's hard to run tests in a lot of psychology. Political science, yeah, it could be true, but it's just not falsifiable. So we have to accept that there are some fields where we have to speculate. Currently, unfalsifiable data has to be accepted in some of these. So it can limit the scope just a little bit in some of these, but at the same time, we have to understand that questions about some of these things are just not falsifiable. So often they're considered beyond the scope of what we would call the hard sciences, which is where we are right now. All right, sorry, I went through that really quickly, but I wanted to make sure that we got to it. Anybody have any questions? All right, make sure you bring your chart, completed chart for the lab next week, because we will be talking it through. Shmuel.
What happens if 100 scientists do an experiment and then 20 and it has one result and 20 do it and it has a completely opposite result? So does that mean that the experiment doesn't work or that the 20 did it wrong?
It could mean any of the above. It could mean, it really depends on that's not uncommon. I'll tell you that happens in the field, that there are errors. Sometimes there could be bias where somebody really wanted something to happen enough that everybody lost a battle to their toaster. Yeah, it could be that there's so much bias that people make things happen by adding to the experiment. There could be contamination of an experiment. This is where, like we're going to do next week when we talk about the Jello lab, why did we get the results we did? We're going to have 15 people, 20 people, however many we've got in our class here. We're going to get multiple different results from the experiment that we do. And that's why things have to be done over and over and over again before they even move into theory. It takes a lot for something to be considered a theory. So yeah, that's a good question, and it absolutely happens. That's why we're constantly questioning our results. We're constantly being open to the possibility of our ideas being disproven. That's the nature of science. One of my pet peeves during all the COVID stuff was how much the media would use the term settled science. It's settled science, because really there's no such thing. Science is never settled. As a scientist, we have to be open to having our ideas changed, having our ideas challenged, coming up with new ideas. We have to be as open-minded as any group of people in any field could possibly be. Not easy to do. It's not easy to be open-minded. We come at everything with a bias. Yeah, great question. All right, terrific job today, everybody. Good to see you. Have a great week. You know where to find me if you have any questions. Bye.
Thank you.
Thank you.